Hello students, welcome to your chemistry class. In our previous classes, we have completed chapter 2, that is solutions. So from today, we will study chapter 11, that is alcohols, phenols and ethers. This is an important chapter for organic chemistry. Most of the important reactions are included in this chapter. Therefore, we have to study this chapter properly. Okay? And today's class is very important because in today's class we will study the basic knowledge related to this chapter, which are applicable in later part of this chapter. Okay? So at first, since alcohols, phenols and ethers contain oxygen atom, therefore let us discuss how oxygen atom is bonded to carbon atoms in organic compound. So oxygen is commonly found in two forms in organic compounds. In one form, two single bonds are present, and in another form, double bond is present. So compounds containing two single bonds are alcohols. And in alcohols, the oxygen atom is bonded to an alkyl group and with a hydrogen atom. Similarly, in case of phenol, the oxygen atom is bonded with one benzene ring and then with one hydrogen atom. And in case of ethers, the oxygen atom is bonded with two alkyl groups. Okay? So organic compounds containing double bond of oxygen are aldehydes, ketones, carboxylic acids, amides and esters. And about them we will study in our next chapter, that is chapter 12, aldehydes, ketones and carboxylic acid. So in this chapter we will study about alcohols, phenols and ethers. Let us first discuss structural characteristics of alcohols. So alcohols have the general formula ROH. That means one OH functional group is attached with an alkyl group. An alkyl group is represented by R. So the general formula of alcohols is RH. We can take example like methyl alcohol, then ethyl alcohol. The second one is ethyl alcohol. After that, the third one, propyl alcohol. In methyl alcohol, one carbon atom is present. In ethyl alcohol, two carbon atoms are present. And in case of propyl alcohol, three carbon atoms are present. So this is the basic information about alcohols, and you have to remember that in case of alcohols, the functional group is OH, and the functional group is directly bonded with an alkyl group. After that, let us discuss the structural characteristics of phenols. So a phenol contains OH group or groups directly attached to carbon atoms of an aromatic system. As for example, this one is the phenol. Okay? In this case, the OH group is directly attached with a carbon atom of benzene ring. So C6H5OH, this is the molecular formula for phenol, and in this diagram you have seen that this represents the structural formula of phenol. After that, let us discuss the structural characteristics of ethers. And in case of ethers, one hydrogen atom of a hydrocarbon is replaced by an alkoxy or aryloxy group. For example, the ether is dimethyl ether. In this case, if we consider methane, that means the molecular formula of methane is CH4. But here one methyl group is present, CH3. That means one hydrogen atom of methane is replaced by the methoxy group. That means an alkoxy group. Okay. So when one hydrogen atom of an alkane is replaced by, or when one hydrogen atom of a hydrocarbon is replaced by an alkoxy group, then the compound obtained is known as ether. So in this chapter we will discuss about alcohols, phenols and ethers. We will discuss their IUPAC nomenclature, after that their general methods of preparation, and then we will discuss their physical properties and then their chemical properties. After that, let us discuss the classification of alcohols. So alcohols are classified into, first, mono, dry, tri or polyhydric alcohols. So monohydric alcohols are those alcohols in which only one OH group is present, and dihydric alcohols are those alcohols in which two OH groups are present. Similarly, trihydric alcohols are those alcohols in which three OH groups are present. So example of monohydric alcohol here, ethanol. Then dihydric alcohol is ethane 1,2 diol, that means ethylene glycol. And then trihydric alcohol is propane 1,2,3 triol glycerol. So you have already studied about IUPAC nomenclature of alcohols in your class 11. And then monohydric alcohols are further again classified according to hybridization of the carbon atom to which the alcohol group is attached. The first, compounds containing sp3 carbon OH bond. In these compounds, the carbon atom to which OH group is attached is sp3 hybridized. That means that carbon will form only single bond. So further, these compounds are classified as primary, secondary and tertiary alcohols. So primary alcohols are those alcohols in which the OH group is attached to a primary carbon. That means the carbon will form only one carbon bond with another carbon atom. After that, secondary alcohols, and secondary alcohols are those in which the carbon atom to which OH group is attached form two bonds with two different carbon atoms. After that, tertiary alcohols. So tertiary alcohols are those alcohols in which the carbon atom to which OH group is attached form three different bonds with three different carbon atoms. So compounds containing sp3 carbon OH bond are further classified as primary, secondary and tertiary alcohols. Then compounds containing sp3 carbon OH bond are again classified as allylic alcohols, and in this case the OH group is attached to a sp3 hybridized carbon atom which is directly connected with a carbon-carbon double bond. Okay, in this case you have observed that one carbon-carbon double bond is present. After that, this one is a carbon atom, and this carbon atom is forming only single bond with its next carbon atom. Therefore hybridization of this carbon is sp3. Okay, and the OH group is attached with this carbon atom, that means with this sp3 hybridized carbon atom, and this carbon is known as allylic carbon. this carbon is known as allylic carbon, and since OH is attached directly with the allylic carbon, therefore this alcohol is an example of allylic alcohol. And then another type is benzylic alcohol. In this case, the OH is again attached with sp3 hybridized carbon atom, but that sp3 hybridized carbon is directly attached with a benzene ring or an aromatic ring. That means this carbon is called benzylic carbon, and in this case the OH group is directly attached with the benzylic carbon. Hence the alcohol is known as benzylic alcohol. So we have discussed classification of alcohols containing sp3 carbon OH bond. So we have learned that there are three types of alcohols present when the OH group is attached directly with sp3 hybridized carbon atom. One is alkyl alcohol, that means we have studied primary, secondary and tertiary alcohols, and then we have studied about allylic alcohols and then benzylic alcohols. Now let us consider compounds containing sp3 carbon OH bond. In this case, the OH group is directly bonded with a carbon atom which form carbon-carbon double bond with another carbon atom. That means that carbon is known as vinylic carbon, and in this case the OH group is directly attached with the vinylic carbon, and hence the alcohol is known as vinylic alcohol. Then let us discuss the classification of phenols. So phenols are classified as mono, dry and trihydric phenols. So in case of monohydric phenols, only one OH group is present, and in case of dihydric phenols, two OH groups are present, and in case of trihydric phenols, three OH groups are present, and they all are directly attached with an aromatic ring or benzene ring. So these are some structures of mono, dry and trihydric phenols. They have their special names we will discuss when we will study IUPAC nomenclature. After that, classification of ethers. So ethers are classified as simple or symmetrical if alkyl or aryl groups attached to the oxygen atom are the same, and mixed or unsymmetrical if the two groups are different. Suppose we are considering this ether, that means diethyl ether. In this case, the alkyl groups, that is ethyl groups, attached to the oxygen atom are same. In both sides of oxygen, two ethyl groups are present, and hence it is an example of symmetrical or simple ether. But if we consider the next compound, that is C2H5OCH3, in this case the alkyl groups attached with the oxygen atoms are different. One is ethyl group and another is methyl group. Therefore this type of ethers in which the oxygen atom is linked with two different alkyl groups or aryl groups are known as mixed or unsymmetrical ethers. So first one is ethyl methyl ether, and the second one is ethyl phenyl ether, and they both are unsymmetrical ethers. So our today's class is an important class because this class gives us an idea about what are alcohols and then phenols and then ethers. So from our next class we will discuss IUPAC nomenclature of alcohols and phenols, and later we will discuss IUPAC nomenclature of ether. But we will divide the chapter in three parts. At first we will discuss alcohols and phenols, and after that, at the end of this chapter, we will discuss about ethers. So in today's class, we have studied about alcohols, and then classification of alcohols, and then phenols. Again, we have discussed about classification of phenols, and then we have discussed about ethers and its classification. So that's all for today's class. Thank you.